going to discuss an important concept in chemistry and human physiology, buffers and buffering capacity. As nursing students, understanding this concept is crucial because they play a major role in maintaining homeostasis, especially in regulating the body's pH balance. Imagine a situation where a patient's blood becomes too acidic or too basic. This can lead to life-threatening conditions like acidosis or alkalosis. Buffers are the body's natural defense against such imbalances. So let's dive deeper into what buffers are, how they work, and how they are essential in healthcare. What is vapor? A vapor is a solution that resists change in pH when a small amounts of acid or base are added. It is made up of 1. A weak acid and its conjugate base, example, acetic acid and sodium acetate. 2. A weak base and its conjugate acid, example, ammonia and ammonium chloride. What is buffering capacity? Buffering capacity refers to the ability of a vapor to resist pH change when an acid or base is added. A higher buffering capacity means the solution can neutralize more acid or base without significant pH changes. To make a vapor solutions, here are the materials needed: test tubes, beakers, Pasteur pipettes, pH meter, and chemical solutions. And now I'm going to show you the steps on how to make a vapor solution. So to start the demonstration, I'm going to pour 25 milliliters of pH 7 vapor solution into a beaker. And then I'm going to pour in 25 milliliters of water. So this beaker contains 25 milliliters of the pH 7 vapor solution. This beaker contains 25 milliliters of water. Next, we're going to add the indicator bromotal blue, and we'll add about 20 drops. Give it a little stir. You can see that we have a nice blue color there. We'll add the same approximately to the water. Then what I'm going to do is I'm going to add hydrochloric acid to the vapor solution. I'm going to add it 1 drop at a time, and I'm going to stir gently. So there's 1 drops that was 3 drops. 2 came at once, so you notice that it's changing more from a blue color to a yellow color. There's 4 drops. Now, let's compare that to the water. See, now we have a sort of a greenish color. We're going to drop this 1 drop into the beaker of water. Stir. And you see immediately it turns very yellow, whereas there is still more of a green. If I squirt the remainder of the dropper in there, I can have them. Both turn a nice yellow, so at the pH below, 7 bromotal blue turns a yellow. It took many more drops of the hydrochloric acid to turn the vapor solution from blue to yellow as opposed to the water. Now, just for fun, let's add a base to each solution. This is 1 ml 1 molar sodium hydroxide solution, and I'm just going to add a few drops in here as I stir. That's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Starting to see a little blue: 32, 33, 34, 35, 36, 37, 38, 39, 40. And you see, we're coming back blue as we're getting closer to a pH of 7. That's about 50 drops. 60 drops and we're back to a blue color. Let's see what we have here. 3 drops and we're back to blue. So the point of a vapor is evaporators prevent rapid changes in pH by converting strong acids into weak acids and by converting strong bases into weak bases for it. Future nurses, we must be able to recognize acid-base imbalances. Thank you for listening, and I hope this discussion helps deepen your understanding of vapors and vaporing capacity in nursing.